Okay, we'll start our courses. We'll start with the state of the art or overview about what we are going to discuss for whole courses. So we start with the intro, the development of many technologies usually associated with the accessibility of suitable materials. Okay, as you know that throughout the human history, um, the breakthrough for each century or each age is defined by the development of new materials. Okay, like for examples, Stone Age, Bronze Age, and maybe now uh, iron, gold, and because we already developed the silicon for semiconductors, we can say that we are now in the information age, uh, which determined by the semiconductors or silicon wafer that uh, established the semiconductors. Okay, here's one video that shows how materials evolve and how smart materials can shape a new future for human. Let me show you the video. So maybe you cannot hear the video quite good, or maybe there's no sound here, but you can watch the video later if you want and review the the whole video. So basically this lady is talking about the of smart materials. Okay, so how smart materials can shape the future and how the smart materials began to develop. Okay, like for example the smart materials can be observed from the early um ancient Egypt, when they built the pyramids. Okay, so one pyramid in Giza, it has the self-healing property, uh, which which are the features of smart materials. So we can see, and also from the uh, piezoelectric, there's a smart material that can have voltage when you push them, or you strain them. It can have voltage. You can see the full video. Okay, it is one of the TD talk, and I think it's quite good video. And this is also designed, um, um, a plane designed by Leonardo da Vinci. He predicted that in the future we will fly through some vehicle. So but differently from average plane today, Da Vinci, he thought that the the wings should have a movement like a bird, and thus the smart materials maybe in the future can help to develop those kind of wings. So when the plane having or experience any turbulence, the wings can adjust itself and then maybe reduce the effect of the turbulence. Okay, so you can watch the video later on. So it's about the smart materials. Okay, so sorry. So let's go to what you need to know. Okay, so for this whole course, what you need to know. So I will give you a little bit material science and engineering lectures from several sections in material science, because that's the material science is the basic of these courses. And then we need to know the classification of materials and advanced materials. So let's start with the material science. Okay, so here what I want to emphasize is there are 6 different properties. So this is mechanical, electrical, thermal, magnetic. Okay, let's start from here. So mechanical, electrical, thermal, magnetic, optical, and deteriorative. Okay, so all of this is how materials can have a significant property, either mechanical, either electrical, thermal. Okay, so we can have a different application or different implementation of that materials. And then one of the important things is the relationship between structures and property of the materials. So imagine, okay, every materials, they have arrangement. Okay, they have different arrangement of atoms, and that arrangement makes the property of materials difference. Okay, so between metals, ceramics, polymers, any materials that you can think of, each materials have different property, and that is because they have different structures. Okay, that's the really basic idea. Okay, so to investigate that relationship, so we need to consider four elements. Okay, so first is processing, structure, property, and performance. So what does it mean? So materials have different structure, and then it will have different property. So to have different structure, you need to process in certain way so that the material have different structure, and thus it can have different property. And of course it will affect the performance. Okay, and then there are also important criteria. So depends on the conditions, depend on the materials during the operation, and then it will affect also cost of the fabricated materials itself. Okay, so this is several points that really basic in material science. And then the other part is the classification. So we will classify all materials. So this is the basic classification of all materials. Okay, so metals, ceramics, polymers, composite. So metals, it composed of metallic elements, okay, like iron or nickel, copper, and all the metallic elements. Okay, and ceramics, it is composed of both metallic and non-metallic. Okay, like usually it is formed in oxide. Okay, if you have like oxide, it's usually it's ceramic. Polymers, it's composed of a long chain of carbon. Okay, it has also other non-metallic elements. And then the composite, the last one, at least composite have 2 different material types. Okay, so you can have polymers, different polymers at one, or polymers with ceramics, or polymers, metals, ceramics. If you mix them and then in a certain way, and they are functional, that is a composite. And then we also have advanced materials. So basically this is used for high technology applications like semiconductors, okay, biomaterials, nanomaterials, and smart materials, which we will discover later in our courses. Okay, so semiconductors, it is a new type of let's say we have conductors, we have isolators, we have superconductors, and semiconductor is in between isolators and conductors. So the interesting parts of semiconductors is you have a small gap, okay, between the valence band and conduction band, and you can imagine like a switch, light switch. So you can have that gap to for example, the electrons, it will uh, excited, right? And then the small gap, meaning you need only a small energy to jump, okay, to jump to the other level. So what does it mean? It means in the steady state, in the normal state, the semiconductor is just like normal materials. But when you are using in electrical devices, then it will performs really, really or conduct electricity really, really well. Okay, so that's the I simplify how semiconductors works. So yeah, but basically that's the semiconductors. And then biomaterials, it's materials that have or used for biological implementations. For example, it has a biology interface, like implant or any medical devices, like biomedical devices. We also say that that's biomaterials. And nanomaterials, materials that reduce into a nanoscale size. Okay, so there's a lot of materials in the nano world, and why does it important? Because okay, nanomaterials, if you reduce the size of the materials into nanoscale, there will be a huge difference in several materials. Okay, so huge difference in property, especially their but it depends on each case and in each materials. For example, gold, you see the macro scale of gold is gold, right? But if you are reduce the gold size into micron or nano level, you will recognize gold with a red color, not gold. Okay, that's one example. And then smart materials. And what is smart materials? We will discuss in the next slide. Okay, so let's say smart. Okay, in smart materials, that this implies, okay, these materials are able to sense change in their environment, okay, and then respond, okay, to these changes in predetermined manners. So it's similar to or approaching living organisms, okay, and it has two components usually: a sensor to detect the signal, okay, an actuator to perform a response, okay. So that's a smart. And then what else we have? Example here, okay. Throughout the courses, I will provide more and more example, but you can observe here. We have shape memory materials, okay. So this example, okay, this is nitinol, so it's nickel and titanium alloy. So if you see the picture here, so if the materials heated, it will become like this, the B, okay, the B. And then if it is cooling, it becomes C. And then deform, you apply force, and it will become A. So it will recycle throughout this process, okay. So what does it mean? After you deform that material, it will revert back to the original shape if you heat that material, if you apply a high temperature, okay. You can see the video here, and maybe you can see by yourself, or watch the video and see the phenomenon, okay. And then piezoelectric materials, you can also see the video and watch the experiment. So basically, piezo if you apply mechanical stress, it will resulting the voltage, and vice versa. If you apply voltage, it will induce mechanical strain. So that's piezoelectric. But that scale voltage or the strain is really, really small. Okay, and you can see the video, watch the whole experiment. Sorry. That's the video. And then magnetostrictive materials is similar to piezo, but they are responsive to magnetic fields. See these materials, when the magnetic fields applied, it's having like a stretching their whole materials there. Okay, see the difference. The other examples is their fluids. Okay, it's either electro or magneto. It depends on the materials. We will touch this discussion maybe later on next courses. So this is a liquid that experience dramatic change in viscosity because of electric or magnetic fields. You can watch the video here. It's really, really fun. You can do also the experiment by yourself, I think, because the electricity that you need is just a static electricity which can come from your hair, like balloon and hair. When you rub the balloon on your hair, it will have the electric static effect. Okay, and this is the idea. Okay, and this is the experiment. You can watch the video, but I suggest you watch by yourself and see all the experiments here. And then the conclusion, the smart materials is having stimulus. We stimulate the materials, and the materials will react. That's basically what we are going to explore, observe. Okay, or we can say that this is a kinetic material. But before we touch the kinetic material or materials that move in the title, we will touch several property and materials in the next lecture. So this is the first lecture. So I hope you get the idea. Watch all the video inside this file. Okay, you need to have internet connection because all the video are linked to YouTube. Okay, thank you. I hope you get the idea of all the